juga.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafizh Ramadhan, NIM 190739091. On this video, I will discuss about computer simulation of a 4-stroke spark ignition engine. 1. Introduction. It is very clear that ideal Otto cycle is ineffective in simulating combustion in a spark ignition engine compared to data measured in a real engine. The problem is simply that an engine cannot conduct combustion at constant volume because a real burning process takes time. The piston keeps moving and the cylinder volumes change. If this latter problem could be remedied by keeping the piston stationary at TDC while combustion took place and then moving it down the power stroke when all is burned, the EMAP and power will increase by some 50%. 2. Mathematical formulation. 2.1. Heat release rate. The heat addition for spark ignition engine may be a prescribed function of crank angle. 2.2. Combustion efficient. The combustion efficient of a gasoline type fuel such as octane can be expressed in terms of excess air factor from measured data. 2.3. Heat release during the burning process. The total value of the heat that can be released from the combustion of the quantity of fuels and is controlled by the combustion efficiency. 2.4. Thermodynamic model. Any case, assume that can be prescribed the equation of state for an ideal gas. 2.5. Work done and volume of the engine. The mean cylinder pressure and the corresponding incremental change of system volume can further express the incremental work done by the system. 2.6. Heat transfer to or from the chart is valid whether or not the key is interpreted as the heat addition due to combustion or the heat loss by the gases in the cylinder because of convection. 2.7. Total friction work for SI engine. The total friction work consists of the major component. These components are the pumping work, which is net work per cycle done by the piston on the cylinder gases during the intended exhaust stroke. Rubbing friction work, which is the work per cycle dissipated in overcoming the friction due to relative motion of adjacent component within the engine and the accessory work. 3. Resultant dissolution. 3.1. Effect of compression relation in the typical compression ratio value for the spark ignition engine was 5:1 or 6:1. Today, the conventional automobile engine has a compression ratio of about 10:1. The real engine does not burn in its full according to the ideal Otto cycle. If the engine has a passed burn, thus the indicated thermal efficiency also increase and in the same proportion with the change of compression ratio as that for the ideal Otto cycle. 3.2. Effect of equivalence ratio. Show the variation of the heat release rate with crank angle position for equivalence of 0.8, 0.9, 1.0 and 1.1. 3.3. Effect of spark timing spark. This is the major operating variable that affect spark ignition engine performance, efficiency and emission at any given load and speed. 3.4. Effect of combustion duration increase turbulence in the unburned mixture at the time of combustion increase the burning rate. Turbulency is usually increased by generating swirl during the induction process. 4. Construction the present work introduce and simulate the combustion process of a 4-stroke naturally spirited spark ignition engine that result from the analysis of measured cylinder pressure data and relates the happenings in the combustion chamber to the burning of a real fuel with respect to time. It can be seen that the simulation of the ideal Otto cycle, the cylinder pressure diagrams, and the predicted overall performance parameters began to coincide with measured data more closely. I think it's enough for this presentation. So for this presentation, I apologize if there are errors. Hopefully it will be useful. Assalamualaikum warahmatullahi wabarakatuh.